Anxiety is one of the most common mental health experiences on Earth, affecting over 284 million people globally according to the World Health Organization. But to understand it, we have to start not with pathology but with biology. Anxiety evolved as a survival tool. The amygdala, an almond-shaped cluster of neurons deep in the brain's temporal lobe, acts as a threat detection system. When it senses danger, real or perceived, it triggers a cascade of physiological responses within milliseconds. Heart rate spikes, breath quickens, muscles tense. This is the famous fight-or-flight response, first described by Walter Cannon in 1915. Modern research has added two more responses to the classical fight-or-flight model. Freeze is the immobilizing response where the body goes rigid, a survival strategy when neither fighting nor fleeing is viable. Fawn, proposed by trauma therapist Pete Walker, is the appeasing response, becoming compliant, helpful, or invisible to neutralize a perceived threat. Each of these strategies was adaptive in ancestral environments. The problem is that the amygdala cannot reliably distinguish a predator from a passive-aggressive email, an aggressive boss from a genuine physical threat. Modern life generates constant low-grade alarm signals to a system built for acute emergencies. The physiological engine behind sustained anxiety is the HPA axis, the hypothalamic-pituitary-adrenal pathway. When the amygdala fires, it signals the hypothalamus to release corticotropin-releasing hormone, which triggers a cascade ending in the adrenal glands releasing cortisol. Cortisol is essential in short bursts, mobilizing energy and sharpening focus. But chronically elevated cortisol damages the hippocampus, the brain region critical for memory and context. This creates a destructive loop. Anxiety impairs the very brain region needed to contextualize and calm anxious thoughts. Research by Bruce McEwen at Rockefeller University documented this hippocampal shrinkage in chronically stressed subjects. Hypervigilance is one of the most disabling features of anxiety. When the threat detection system is chronically overactivated, the brain begins treating ambiguous stimuli as dangerous by default. A friend who did not reply to a text becomes evidence of rejection. A physical sensation becomes evidence of serious illness. This attentional narrowing, what researchers call the threat monitoring bias, means anxious individuals process neutral information differently at the neural level. Neuroimaging studies show greater amygdala activation in anxious individuals in response to neutral faces compared to non-anxious controls. One of the most counterintuitive findings in anxiety research comes from Harvard psychologist Daniel Wegner. His ironic process theory, established in a famous 1987 white bear experiment, demonstrated that deliberately trying not to think about something increases how often that thought intrudes. Wegner asked participants not to think of a white bear, and the bear promptly colonized their thoughts. This metacognitive trap is particularly relevant for anxiety. The act of trying to suppress anxious thoughts can paradoxically amplify them. Acceptance-based therapies like ACT, acceptance, and commitment therapy, use this finding to teach psychological flexibility rather than thought suppression. The most evidence-based interventions for anxiety work not by eliminating the threat response but by modifying the brain's relationship to it. Cognitive behavioral therapy teaches individuals to examine the evidence for anxious predictions and construct more accurate appraisals. Exposure therapy works by activating fear in a safe context repeatedly, a process that drives extinction learning in the prefrontal cortex. Neuroscience research confirms that mindfulness practice strengthens prefrontal cortex regulation of the amygdala, essentially building the brain's braking system. Anxiety may be universal, but its intensity, duration, and impact on life are genuinely modifiable.